Alright, chemists, let's look at electronegativity and how that affects bonding. So the goal of this lesson is to be able to use electronegativity and use it to predict the type of bonding that's going to occur between two atoms. In that case, we're talking about the Linus Pauling scale, or the Pauling scale. So this is your vocabulary. If you can just copy this down, we'll be able to refer back to it as the lesson goes on. Remember, pause at any time you want, like now, and yeah, you'll always be able to check your work. So what is the Pauling scale? The Pauling scale is a numerical scale, and it's between 0 and 4. And it increases left to right across the periodic table, and it increases from down to up, or from bottom to top. The differential between the electronegative nature of certain atoms as they exist on that scale, that's what determines the type of bonding that's going to occur. And the differential also not just determines the type of bonding, but it determines the polarity of that bond. Will it be a polar bond, or will it be a non-polar bond? If we're talking polar and non-polar, we're talking about covalent bonds. So let's have a little reminder on types of bonding, right? So we've got chemical bonds such as ionic bonds, and we see here that the one atom is giving an electron to the other, so they transfer electrons. And when we look at covalence, we see that they're sharing electrons. And then we've got metals, where they just sort of throw electrons all around the place. Now, we're not going to talk too much about metals in this lesson. We're going to save that for another one. But it's related. It's in that system. The polar covalent bond, that's one where you have the electrons being pulled more to a certain one. Water is a good example in this case, or in this case we're talking about hydrochloric acid. The electrons are pulled towards that more electronegative element. And over here we've got two hydrogens which will have the same polarity. Therefore, they are more likely to share the bonds equally. Now, if we think of this in terms of what electronegativity is, which is the power of an atom to attract electrons to itself, this makes sense, right? Over here we have an electron with a high Pauling scale and one with a medium Pauling scale, which means it makes sense that this one is going to be able to attract or pull those electrons that they're still sharing at this point, together. When we look at an ionic bond, we're looking at a metal which is going to have a really low electronegativity, and a non-metal, like particularly a halogen, which is going to have a really high electronegativity. So in that case, the pull is so strong that it takes the electrons away from one. So away from the more electronegative, so from the less electronegative to the more electronegative, and that transfer of electrons is what then attracts those two ions together. So this affects bonding, right? So the way it affects bonding is ionic bonds occur when we have, so that's complete transfer of electrons. And these occur when there's a differential of greater than 2. Covalent bonds, which are polar, occur when we have a differential less than 1.7. So in between the 0.7 and the 2, it's kind of not really an ionic bond, it's not really a covalent bond, it's somewhere in between. So it's not a complete transfer of electrons. But when we get less than 1.7 and down to about 0.6, we see polar covalent bonds. When the difference is only about 0.5, we get a non-polar covalent, which means actually there's equal sharing happening. So in covalent polar, there's sharing, but it's unequal. The more electronegative will hold the electrons closer to it. And in a non-polar covalent, there's actually an equal sharing of electrons. There are overlaps between these. These aren't perfect standards. There's overlaps and gaps. And this is where it's actually time to start thinking of bonding as not being this or that. It's actually a spectrum in between. So some things are purely ionic, some things are purely covalent, but some are in the middle there, just a few. And yeah, so that's where this comes into it. I hope that made a lot of sense. And if it didn't, put any questions you have in the comments below, and we'll get back to you as quick as we can. Subscribe so you can keep up with what we're putting out there. And yeah, thanks for watching. See you next time. Bye now.